All right, welcome back, everybody. We're going to be working on 4.7c today. This is application problems with displacement. Displacement basically means with phase shifts. That's the one thing that we have been leaving off with all the problems we were working on yesterday. We did not have any phase shifts. Today we're going to get those phase shifts. So it says you will be able to write the equations for real-life application problems that have displacement, aka phase shifts. So let's take a look at what this looks like. So John is floating on a tube in a wave tank. At exactly 1 second, John reaches his maximum height of 14. So here's 1 second. Here's where he hits that maximum height of 14. It says at 9 seconds, John reaches a minimum height of 2 meters. So his minimum height will be 2 meters. That happens at 9 seconds. Now, again, we have not completed a full period at this point. We've only went from high to low. We got to get back to high. So our distance in between here was 8, so we know that we'll be back up at our midpoint after 8 more seconds, which would be at 17 seconds total. So here's where that happens. I'm going to slide this over just a hair so everything's happy. Now 14 meters was the highest, 2 meters was the lowest. Now we're going to come in and we're going to draw in our midline. So here's our midline coming right through the middle. Our midline is going to be halfway in between the minimum and the maximum. To find that, you just take 14 plus 2 divided by 2. 14 plus 2 is 16. 16 divided by 2 is 8. So that will be our midline. We're 6 above and 6 below, so that's going to give us our amplitude for later. So we can sit there and sketch a graph of our function. So we come down, we're going to hit our minimum, and we're going to come back up. Kind of poor drawing, but you get what's happening. Again, you can figure out exactly where you're crossing that midline just by looking at what's exactly halfway between 1 and 9. 1 and 9 is 8 units apart. Half of 8 would be 4, so 9 take away 4 would be 5 here. 9 plus 4 would be 13 here. Those would give us those middle points. Now we want to write a function for this one. This one, since we're not starting at our midline, is going to be a cosine function. Our amplitude is 6, so we're going to put that out in front. Now, again, we are modeling the height of John with respect to time, so we're going to say h of t. 6 is positive here because we're starting above the midline. If we start below the midline, it'd be negative. Again, we're going to leave our b value off. Now, this one we do see that we have a phase shift, right? Our graph has been shifted 1 unit to the right. So since we've been shifted 1 unit to the right, we're going to say t, remember we do this opposite, minus 1. That's what would shift us right there. Our midline here is 8, so we're going to say plus 8. And then the last part, we got to figure out our b value. So again, we got to know our total period length. Our total period length here is really, it appears to be 17, but it's actually 16, right? Because we've already been shifted over that 1. So we're going to take our 2 pi over 16 to figure out what our b value should be. This would make this into 1 pi over 8, so we're going to say pi over 8 right here. And this would be the function that models it. So a couple things to realize here. That phase shift does not have too big an impact. It's not too hard to actually adjust for. Instead of this always being a 0, now we're just going to move it to wherever our graph starts. The hardest part is really putting it together and saying, where is my graph starting and what does this actually look like? Here's another problem. I think we have 3 today, so this is number 2 of 3. It says a mass bouncing up and down on a spring hanging from the ceiling. Its distance y from the ceiling varies sinusoidally. That means it's either like modeled by a sine or a cosine function with time, t, seconds, after making a complete cycle every 1.6 seconds. At 0.4 seconds, so here is 0.4 seconds, y reaches its maximum height of 8 feet. So at here, we're at 8 feet sitting right there. And then it says the minimum it gets to is 2 feet. We're going to have to do a little investigative work to figure out exactly when this works. So here's what we do know. We make a complete cycle every 1.6 seconds. So if I'm starting at 0.4, I know I would wrap that up. 0.4 plus 1.6 seconds would mean 2, right? This would be our period of 1.6 seconds. So if that's my full period, that means I'm back up to the top at that point. Halfway between 0.4 and 2 would be when we are at our lowest point. Now, if you can't sit there and figure out where that is, easy way to do it is to take 2 plus 0.4, divide that by 2. So we're going to get 2.4 divided by 2, which is 1.2. That is when we are at our lowest point. Now, officially, this is actually all we need in this situation because we know we're going to come down and come back up. Now, we do still need our midline here, that is, right? We can sketch that in. Halfway in between 2 and 8 would be 5. That would be 3 above and 3 below. Again, you can find that by taking the average. We have a cosine function here, so we would take our amplitude, which is 3, times our cosine of, now again, we're modeling the height of this with respect to time, so we're going to say h of t again. We're going to say t, and then we know that our midline was 5, so I can say plus 5 already. Now, it does look like our graph was shifted to the right, 0.4 here. That's where our graph's actually starting here. So we're going to say minus 0.4 to account for that phase shift. Now, our b value is going to be found just by taking 2 pi and dividing that by our period, which is 1.6. 2 divided by 1.6, let's pull a calculator out here. See if we can get a nice number out of this. 2 divided by 1.6, 1.25, and then if we math frac that, that would be 5 pi over 4. This is the same thing as 5 pi over 4, which will be our b value. So we'll put our 5 pi over 4 right here, and this would be the function that models the spring. Now, again, in this situation, just so we're all on the same page, the phase shift part, the only part that's new to us today is literally this number right here. We just got to adjust, and the setup looks a little bit more confusing sometimes, but that's all that's going on. If you can take that information and put it together, you're in good shape. I believe this is our last one. Here it is. It says, researchers find a creature from an alien planet. Its body temperature varies sinusoidally with time. So 35 minutes after they start timing, they realize that the body temperature of this alien reaches its high of 120 degrees. 20 minutes after that, it reaches its next low temperature of 104 degrees. Sketch a graph and write the equation expressing temperature in terms of minutes since they started timing. So here is what we know. We know the high temperature of this alien is 120 degrees. We know the low temperature of this alien is 104 degrees. They found out that 35 minutes after they started timing, it reached its high temperature. And then 20 minutes after that, it reached its first low temperature. So 20 minutes after 35 would be at 55 minutes. It's going to reach its low temperature. Now, again, we've not completed an actual cycle or period. We got to go back to the max. So add another 20 minutes. We should be at our maximum. That would be at 75 minutes total. We get up here. Now, again, the function for this would look something along the lines of this. It's a little snippet of a cosine function. Couple things we got to realize. Our total period distance here is 40 minutes, right? So 40 minutes is what our actual period is. Our midline in this situation would end up being, so 104 and 120 are 16 apart, so that would be 8 off, so this would be 112. You can also do that by taking the average of 104 and 120. Now, that's our midline. Do we need anything else? I don't think so. We do need to know that these are 8 apart and 8 apart. So, again, we have a cosine function here. Our amplitude is 8, so we can put an h out in front. Now, we are talking about temperature with respect to time. So, let's just say big T is temperature, little t is time. So, temperature with respect to time is going to be 8 cosine. We're going to leave our b value off right now for a second. So we're going to say little t time. We were shifted to the right 35 units. So since we were shifted to the right, we're going to say minus 35 here. And then our midline was 112. Now let's just get our b value. So to get your b value, it's just 2 pi over your period length, which was 40. This would be 1 pi over 20. Which is our b value. So 1 pi over 20 goes right here, and this would be the equation that models it. That is it for today. Your homework is going to be, I think this actually should be, say, 4.8C. 4.8C. It's whichever one's posted in Schoology right now for you. Thank you guys so much for watching. I hope this was helpful. If you have any questions, please make sure you reach out. Have a great day.